Student Speaks, conducted by the ISTE NITC Students Chapter. This is the third edition of our monthly webinar series where we bring in an inspiring and impactful guest to talk to us about their experiences and leave us with something more than we would have thought. Our aim with this event is to bring in a speaker who thinks outside the box, a pioneer like Newton. And I feel like Suyash sir and his team at IIT Madras really, truly embody that spirit. So we all have heard of Hyperloop. We've all heard of Elon Musk SpaceX, but combining the two, we have Team Avishkar Hyperloop. So they're a student group from IIT Madras, which participated in the SpaceX Hyperloop pod competition in 2019. In fact, they were the only Asian team which was selected among 1,600 teams. And they were out of 1,600 plus teams, they qualified to be part of the 21 finalists, and amongst that, they were part of the top 10. So that definitely is something we can look up to, and that is definitely something that we can be proud of. So thank you, sir, for joining us today and talking to us about more about this futuristic transportation technology and how Team Avishkar really got to that stage, you know. So it's not dally-dally anymore. So to the attendees, if you have any questions, please feel free to address it to the host via the chat box. We shall address them at the end during the Q&A session. But without further ado, let's move on to the talk. Over to you, sir.
Thank you, Ella. And it was really a kind introduction. And, definitely me, my team are even prouder than all of us together that we have done our country, and we have taken our country's name to a position where it's important to have ourselves as a taken edge in technology with the rest of the world. So, all right, let me start the start with the presentation. And my presentation is not a story at all. It's more of a technology team that we are. We are more like a think tank rather than entrepreneurs who are a lot of stuff like fundraising and all other things. So share a few slides which will give all of what about the journey of our team and how exactly and what we did. All right, so a brief about me before going into that. So I am a postgraduate. I was a postgraduate student at IIT Madras, pursuing my master's in aerospace engineering. So while I was there in 2017 when I joined IIT, so the story is like, when I joined IIT, one of my friend who was in MIT, we had a call, and has been going on in the student community. And we talked for a while, and I got to know that they and their teams and a lot of good US universities have been participating in this competition. And I've been a big fan of Elon Musk since a long time. And there, the idea sparked, why can't our country, or why can't an institute like us can do something like this? And it was new. Definitely, there was no literature available. Hardly a bunch of research papers were there on Hyperloop to understand what it is. And all of that has to be done in just 8 months, designing, fundraising, procuring, manufacturing, everything. But still, I thought, why not give it a shot? And from there, the journey actually started. So I'll tell a little more about that at the later stage. But let's just understand, so this picture will be kind of telling you the other 4 modes of transportation. So what we call Hyperloop is as the 5th mode of transportation. So the other modes, as we know, that cars and buses, which is road, the road transport, all of these are cluttered with traffic and a lot of pollution and other stuff. So, and also these are very slow, and unless something like electric vehicles, lane keeping, autonomous vehicle doesn't come, it doesn't make much sense. And when it comes, it adds to more complexity. Then we talk about airplanes or flight, basically the air transport. The it's expensive, and of course it is lot safer today. But still, while boarding the aircraft, you need to go through a lot of safety procedures. Like you need to understand how to put on your seat belt and what to do in an emergency situation, etc. So it's expensive. At the same time, you need to go through a lot of security procedures. Then we come to water transport. It's extremely cheap, but extremely slow. I mean, a shipment from LA to India will take approximately 1 month to come, which is too huge and makes no sense. Now, trains are extremely reliable, rails are extremely reliable, but again, it's not that fast and a little expensive if we talk about good trains and other countries. So now combining some of the good characteristics of all these four modes, Hyperloop has been proposed. So this is called the fifth mode of transport. What happens exactly in this transport in this mode is we try to completely reduce and eradicate all forms of friction, and make it cheap as road, reliable as rail, and fast as aircraft. Now, just a pictorial representation, you can see that the speed comparison graph, where you can see all the other modes have been somewhere around or less than around 200, and only aircraft and Hyperloop goes to close to 1200. But aircrafts, it's very expensive. It is very expensive today. And if Hyperloop comes, and which is of course happening, it will beat the prices of aircrafts as well. So Hyperloop, right? Now, Hyperloop was proposed by Elon Musk, as we all know, in 2013 in a white paper. And in that white paper, he explained what is the concept and how exactly it is different from other modes of transportation. So as I told in the beginning, that Hyperloop primarily try to eradicate all forms of friction. So as we know, when we move on road or anywhere, there are two major friction that we encounter. One is the air drag, another is the contact friction. So to remove the air drag, we use vacuum tube, which is so that is why vacuum tube or this concept came, which helps the pods or vessels or vehicles to move inside the tube without any air, and thus there is no air drag, which is completely saving our energy to move from place A to place B. Now we have all, some of you who have read mechanical engineering or a very basic equation, which is rho AV square for air drag. Now V square means the force which we need to overcome putting the body in motion is proportional to the square of the velocity in case of air drag. But if we completely remove air drag, we are saving that kind of force and energy. So we are saving on that. The other mode of friction, which is contact friction, is removed by the levitation techniques. We all know that there are a few good trains running in Japan, China, like Transrapid and Transrapid in China. These trains are electromagnetically levitated. So there are three major, successful levitation, which you can see in the picture also. So these are the three modes of levitation, the help of which the pod actually levitates inside the tube, and then you move. And that is how you achieve 1200 kilometers per hour. Just recall your, first ever physics chapter in your 11th standard, and the first law of Newton, first law of motion by Newton, which is any object which is at rest will remain at rest until unless a force is applied. Similarly, any object which is in motion will remain in motion until unless there is no external force which is applied on the body. So when a body is moving in vacuum and when body is levitated, there's no external force which is getting acted on the body, or there's hardly very less. because of the leakages in the vacuum. So that is why we just have to give it an initial catapult velocity and it moves till the end. So that's what Hyperloop. All right. So okay. Uh, there are sufficient modes of transportation. You can move from one place to another, but I think that's not hassle free. And with the ever growing need of supply chain and human population, you definitely need a higher capacity. So these are some statistics you can see in the slide that 80%. There has to be 80% increase in passenger miles in 30 years, as well as 88% increase in freight tonnage is going to happen by 2035. So what is that we are going to do? Bigger airports, more trucks, more trains, wider highways. What is that? So ultimately, you are going to scale every mode of transport which is available. But this is the time where you have to disrupt, come up with the most energy efficient mode of transport, the most less maintained mode of transport, and you need to put some kind of capital. Every government has to do that, and that is why Hyperloop is a very important technology to implement. Now, so this is what Hyperloop is. Right? Now, what exactly student community or a team like Team Avishkar is doing here? So we basically found an opportunity, as I told you as I told the story in the beginning. The opportunity was SpaceX Hyperloop pod competition. So it has been organized for 3 times, I guess. They have stopped it because of COVID, and there might be a change in track this year. But essentially, SpaceX Hyperloop pod competition provides you enough infrastructure to build your pods, a prototype of the pod, and run it. And you are not restricted by any rule book. So, for example, if you go to formula competitions and bar competitions, you will be restricted by a rule book where you cannot have wheelbase greater than this, greater than that, and all other things. But here you can innovate whatever you want. So from the world, different part of the world came up with air levitation. Some teams came up with electromagnetic levitation. Some teams came up with on wheel configuration for Hyperloop pods and other stuff. So this is a great platform, and we also exploited the opportunity to participate. And as Raida explained in the beginning, we were the only Asian team got selected, and we also made the first autonomous pod in India. And this is just one picture of the pod that we designed, and when we manufactured it, to what it is looking like here. Now this is more like a power tray, and the vessel where people will be sitting and where the goods will be set up will be on top of these this. So as a part of the prototype, there were several things that we did to win the competition. But at the same time, we were not just trying to do this, trying to win the competition, but we also ran few research projects inside the team to make cost-friendly and affordable technologies for magnetic levitation. So now let's talk about Japanese maglev or Chinese maglev, which is transrapid. Are hugely expensive because the electricity or the current is running along the track, across the track. But we were trying to come up with a passive magnetic levitation where infrastructure is just the conductor, just like a rail line which is running from place A to place B, and we just have some configuration of magnets below the pod, and which will allow us not to have not to consume so much of power to run Hyperloop pods continuously and levitate continuously. Similarly, we were also trying to a very cost-friendly linear induction motors, which is empowering or basically powering the pod or giving the initial momentum which it will need to go from 0 to the top speed. It can be 1200 kilometers per hour in the scaled up Hyperloop model, and for prototypes it can be up to 500 to 600 kilometers per hour. And this is the landscape of all the teams in 2019 competition, where we were the one from Asia, and there were a lot of teams from US, Europe, and one from Australia. Right, and just a little bit about the technologies. So you can see the technology stack. So it is more like a sub-level technology stack, which is there. And as you can see the different boxes, we had different teams, and different team leads for each of the system. And this is one snapshot from the control system. So what on the final day of the competition, what we had to do is we had to put our pod into the vacuum tube, and once the vacuum was created from one atmosphere to almost near vacuum, then we had to launch. And before launching, we have to do a lot of checks, like brakes are working fine, and the pod is rightly on the track, and not bulging. They are at the right pressure and right temperature, motors at right temperature, and then we finally launched the vehicle. And then you can see the acceleration versus distance graph, or sorry, velocity versus distance graph in the below portion. And yeah, so this journey wouldn't have been possible, if we wouldn't have raised funds. And there were a lot of sponsors which helped us to get through the alumni support, and of course, a lot of people in our country came up fund us in the crowdfunding. And we plan to give back to the community by launching another competition for Indian colleges and Indian students, which will be launched next year maybe. And that competition will provide you a similar infrastructure which is there at SpaceX, and it will be called Indian Hyperloop Pod Competition. So that's the idea. All right, so this is from the presentation, and one last thing I would like to mention before closing would be, when I started this thing in 2017, and I found a group of members, there was a lot of reluctance and there was a lot of resistance. And every member of the group has their own vision and mission. While they were in college, someone wanted to go to some grad school, someone wanted to get the best placement, and someone wanted to do a research work, a lot of other things. But when all of them came together, we were able to see the same vision, and that is why community or the student team that we brought, that came together, had a very strong vision, for Indian transport, as well as a mission to take India to that map where the Hyperloop is going to grow, and as a technology and as a disruptive technology. So what I can say is, if we can do it, we can do it. So, if you get a chance to do something like this, go ahead, do it, and you'll be able to do, because I understand when we were there to make everything in just 3 months, be it from the fund side, be it from the project management side, it all happened. You just have to keep at it. And yeah, Raila.
Yes, thank you, sir, for that. And definitely, teamwork makes the dream work. Yes, and like you said, the dream may seem very impossible, but then you've just proven that impossible dreams can still be made possible, even though no matter how Herculean they may seem. Yeah. So I've already gotten a few questions. Let me just get to them. A lot of it is about Hyperloop itself, because I guess many were interested when you gave us a brief description about that. One second. So yes, what are the problems that could be countered in developing a Hyperloop system in India? So you talked about like how we can go fast and how it's a much cleaner source of energy. But is there something more to which, why should India invest in it, even though we are a developing country, and some may counter that poverty is a more striking issue. So,
I think India is one country where we should definitely do this technology. Why? Because yesterday only I read one news where there is a upcoming Ganga highway where we are spending around 36,000 crores. Right? If we spend that kind of money in infrastructure like Hyperloop, then the cost of running, so capital cost is definitely a lot. We understand that, but cost of running can be drastically reduced, and people who are staying very far from their offices or city and from homes can actually travel with that. And after a time, you need to have such kind of disruptions because population and the utilization of resources is going and growing exponentially. And after a time, you cannot have linear modes of transportation to fulfill every exponential demand going ahead. So Hyperloop can cut short your time, which is very important. Maybe it will not target everyone in the beginning, but after a while, it will definitely, just like smartphones. So when it was invented, only rich people, now today everyone can afford it. Similarly,
yes, true. Like 20 years back, it was about computers and internet was such a taboo topic. But now AI and machine learning are booming, and it's like the lifeblood now of the future. Now, following up to what you said, even though it may be a smart investment, maybe there might be a certain set of people who are apprehensive of Hyperloop or its effects, and whether it is like really that much of a future technology. So how should it be advertised and marketed to them?
In a frugal world, nobody wants to invest a huge amount of money upfront and get nothing in return in 10 years or 20 years. So we have been trying that, but of course, things will take time. But the answer to your question is we need to develop affordable technologies. We need to demonstrate that a per mile cost of a Hyperloop track can be 10x less than a bullet train's infrastructure, or a Maglev trains infrastructure, and we have done that. So we have been on a simulation level and a PO make a Hyperloop track in just $5 million per. The bullet trains cost is approximately $30 billion US per kilometer. So that has to be the way. We need to be full. We need to make develop affordable technologies.
And like like Team Avishkar is trying to bring in a Indian Hyperloop competition, that would also really help bring and raise awareness about this technology.
Absolutely.
Now, another question that came up is, so the pandemic must have severely impacted your progress. Yes, I believe you were set to participate in another Hyperloop competition, but then the COVID really struck down on that. So how do you keep yourselves motivated during this time?
So as I said, our vision was to make a mark in the global map of this technology. So it's not that we want to win the competition someday, because competition is more of demonstrating the highest speed in the tunnel or in the tube. So it's more of my teams and my professors and my institute's vision is more of developing this technology for a longer run. And that is why, this pandemic has given us even bigger edge and time to think over plans of putting up Indian Hyperloop pod competition so that we can bring in more talent, more innovations into place, as well as, talking to government authorities to how it can be done and other stuff. So it has been a okay situation. So we had a lot of work. We didn't have the time to think about how to get motivated. Yeah.
So in the earlier situation when there was no pandemic and life was good, how did a day at the workshop look like?
So there was no day. It was only nights. Because most of the people are students in the team, and only a couple of or 3-4 people are project associates, and they are also planning to join some other thing in near future. So it was always the night from 2017. It was never a day, and we used to work nights. So typical, day completely depends on what milestone we are targeting. So when we are targeting a design milestone, then we are just sitting down, brainstorming, doing simulations. When we are actually manufacturing something, then it's a different game. And assemble things, put up the test bed, and do this.
Yeah, all right. So now another question that has come up is, even when you face your lows, there will be ups and downs in this journey. How did you constantly keep yourselves motivated? Because I'm sure not all of it must have been a smooth sailing. So how did you cope with those failures? And on the same note, how did you celebrate the successes which you guys had?
So we had, very less time to celebrate anything. Of course, those were a lot, definitely, because the kind of curriculum that we are into, and most of the institutes are into, is very tough. To leave you without your assignments and all those stuff. So it's very tough to manage time and so work out of it. So yeah, I think the most important thing that we were always discussing is doesn't matter what kind of compromises we are going to make in the design, or what kind of changes we are going to make in the design, or how many changes we are going to make in the design. We have to do it, and it's a culture, the culture that we have in the team, which actually built up with time, was impeccable and awesome. So I think there was not much of the motivation. It was all my shouting when people were not worked out. So I can't complain.
I guess if you have a good team which is working towards the same goal, as long as you're all passionate and on the same page, wonders can be done. Now, another question has come up. It's a little bit more cheekier, I would say. So you've been on an international standing, yeah? So is it true that Indians are the best engineers out there?
I won't say that, but what I can say is Indians can perform the same job and in a very, very less. That's true. Everyone is
that's a very democratic answer. Yeah. Now, this is a question we like asking. This is a question. Yeah. Now, this is a question we like asking all our speakers. If you could recommend one book to the audience, which one would it be?
If you're going to ask me this question, I'll say go read Elon Musk. It's important.
I mean, that's expected.
Yeah. So I think I only had time to read that book, nothing else.
Actually, you did get to meet Elon Musk during the SpaceX Hyperloop pod competition, right? How was that? I mean, I'm pretty sure all of us, it must be like a dream for all of us to meet the Elon Musk himself. So How was it for you to meet him?
Of course, I think we were looking forward to meet him. So what happened was I went in 2018 as well. I was also invited for that competition. So that year we didn't qualify. We qualified in 2019. So that year I went and I saw everything, and I just had some kind of thought process that what Elon is going to do after the event and all these things. So we were ready for that, and uh, the thing is, of course, as you said, it's a dream come true, and it really everyone wanted to talk to him, everyone wanted to meet him, and I was literally a little more fortunate being the team leader of the team that I got to interact a little more with him, and of course, nobody will be able to understand anyone in 5 minutes, but what I understood from him, like two key learnings. One, he said, if you're wasting too much time in doing design and simulation, then definitely you're doing something wrong. Stop it and try something. That's one of the could have heard from him. And second, he talked about our team, like being from Asia doesn't matter, because most of the Tesla facilities are there in Thailand and Vietnam and China. So it's okay that you can still work from there. And of course, he talked about Tesla. Oh, it was great. And one of the two key learnings were very important.
I'll get to a related question about Hyperloop. Where do we get the material to learn how to make a Hyperloop pod? What was your starting point? Because if there is someone who is interested in this technology, what would you suggest to them?
So that's an interesting question. Actually, when we started, there was hardly any literature to start with. But what you can do is, go through the SpaceX Hyperloop pod competition rule book. Uh, Not a very typical rule book, but you'll still get an idea of what exactly they are trying to ask, and what constraints are there as the environment, and then you may probably want to go through the patents. There are a few patents filed by Virgin Hyperloop One and Hyperloop Transportation Technology. So go through them. You will have an idea of the concept, and then probably you can do a system design and get started. So I think it's learning by doing more than going and reading.
All right. So another question that has come up is, by when do you see Hyperloop running in India?
So there are very repetitive questions that I hear every time. One is, how was the experience with meeting with Mr. Elon Musk, and second is, when is Hyperloop coming to India? So what I can say, I because it may take a little more time. But what I can say is, it can be 5 to 10 years from now. You can definitely see something running. But I'm not sure how affordable it will be, because technologies take a lot of time. There are other legal compliances that we have to undergo. But yes, 5 to 10 years, first prototype will be definitely there.
You guys are making conducting a competition on your own. Yeah, the Indian Hyperloop competition. So what are the key factors that should be considered, and what are some of the major challenges you faced along the way?
So it's still a little, very much a concept right now. We have planned it to be organized next year in June 2021, but it might get delayed. Think the major challenges will be the environment or the temperature conditions in Chennai, because the tubes will be of metals, and we know how, or we can go to a civil engineer and design roads or probably even rails, because they have been there for a long time. But designing a hyperloop track requires these conditions to be evaluated properly. So, and there's a lot of humidity in Chennai as well, so it might get rusted very early. So these challenges are there, which we are facing to design the track. And apart from that, I guess, of course, the funds which will be required will be again a little more challenging. But I think that can be pulled off a little, but other things are still there.
On the topic of funding, of course, it must have been now it must be easier because you guys have had an international standing and you've participated and proven yourself in so many different platforms. But in the initial stages, when funding was so low and when people were still very vague about the idea, was there any time when you thought, is this worth it? Is it not worth it?
So actually, we always thought that this is worth it. But people, when we met them, they wondered that is it worth it? And so a funding process was really, a pain, and it was really painful. And those 3 months, I can remember that people that they were in college. So one problem was there was the drought condition in Chennai in 2019 summer, and we were literally kicked out of our hostel because there was no water there, and we had to stay outside in PGs and come back to institute, bicycling, and in that time also we had to work 24/7, and that to not just assembling the pod, it was also talking to people, networking, and trying to raise funds. And so one thing is definitely there was a lot of. Second thing is just because this was very new, I guess it goes just like the book that we have learned, Crossing the Chasm. There are some early adopters of the industry. There are some laggers of the industry. So when you talk to early adopters, our main idea or main thought process was to convince those early adopters. I mean, who are literally very techy, who wants to do innovation. And so we targeted all the innovation wings of the corporates to make them understand the concept and quickly get into the funds, because we want them to write the check in just 2 weeks. Don't take too much time. 2 weeks it is. That's it. Yeah.
All right. So another question which has come up is, so is there any takeaway from your college life that you apply to, while working in Team Avishkar?
I didn't get the first part. Is there any?
Is there anything like from your college life, especially that you use in Team Avishkar? Something that some skill or quality that you may have picked up.
So I guess I am not the right person to answer that question. It's more of my team members, because the day I went inside college, my master's started, and I literally my 2 years of masters was more half-time Hyperloop and half-time studies. So I think yes, technically I would say a lot of things, a lot of concepts that we utilized came from our class, and we also discussed several bottlenecks with the professors. Apart from that, no, I don't think so. There was not for me much, but there was one guy who discussed something that we have implemented in the project. So there's a course called Design of UAVs. So he was in aerospace engineering BTech, and he was designing a drone just to payload and run it from one place to another. And he told me, we should possibly do go ahead with this particular design methodology, and that really worked out for us. That was one. And other stuffs are like typical jugaad, which we do in our hostels and everything. So that also came out really
well. So, like you said, there is a significant gap between what we learn in class and what we are able to apply to the world. Only if we are part of some projects or anything that technical can we bridge that gap between practical knowledge and what we learn in class. Now, what would you suggest? What would you advise students who are stuck to their classrooms? What would you tell them to try and develop their other skills? And how can they as well?
Right. So I would say, figure out a problem, which you want to solve, and then go after the technology of the concept. So, in your first semester, second semesters, you don't have much to do or just figuring out the world of these things. Maybe you can just pick one simple problem, or a little more complex problem and figure out how it has been solved before, and then try and approach these things. So for example, uh, autonomous vehicles is one problem, and then how you go ahead and apply algorithms using lidar, radar, and camera is a different story. Then you go ahead and check what lidar is. Then it will make sense to you. Otherwise, what lidar is just lidar. You don't care what lidar is. So I guess taking a problem statement approach is always good.
Now, on the same note, I mean, innovation is very important for the future. Yeah, and I wouldn't call you a startup, but then again, you started off as at an innovation cell and all that. Now, many people are afraid to take that first step sometimes towards innovation because they're so afraid of the risks and everything. Yes, but then. And maybe they don't know the necessary skills like marketing, business, network. What is your advice to these people?
So, as you said, that the first step is very difficult, and that is why I was a little fortunate, and I would say I was not knowing at all about these challenges when I was taking the step, and that gave me a lot of power, And it was like, we'll see it, and all those things. So I just see that you have formed a 20-member team or 5 to 10-member team, and everyone is dependent on you. The leadership load will always give you power and motivation to learn. So for example, I never knew about fundraising stuff or all these things, but I eventually got to know, talking to my seniors, talking to express people and all these people. So everyone will be giving you some kind of learning, right? You just have to take it and apply it in a right way that you want to. So I guess I'm also now doing my own startup, which is again in deep tech. I'm just starting to do that. So I'm also facing those challenges, but I'm literally a little lucky that I have been in this phase. So it'll easier to focus on the areas that I don't know yet.
And experience is always the best teacher, yeah. Unless you take that first step, we won't get the experience to learn. A question which has come up is, how did you meet your team members who were equally interested in this concept?
Yeah. Okay, so there is a culture. Yeah, so there's a culture inside our institute already in place. There's a culture in our institute, where we have a center, which is called Center for Innovation, and we call it C5. There are student body and managing student body who helps you to kick off the project, and maybe also help you to put up an email which can be circulated across the students inside institute. And so I was just doing this exact similar things which anyone will do, like shooting emails to every student with a registration form and asking them to fill up the regular application form if they're interested, and putting some posters and doing some videos. So it's a hit and trial process, I would say. You don't get like-minded people on first day. They get like-minded after, because what you are seeing in the first place, they might not see that in the first place. You have to convey and articulate properly, and then only you'll have those people by your side.
So since we're already nearing time, I think we can wind this up with just 2 more questions. So what can you describe 3 major takeaways from your past 3 years at Team Avishkar?
Tough question.
It's just breaking up it. A very tough question. Yeah, I guess like 3 years, sum it up in 3 sentences is not easy.
Exactly. It's a tough question, and I don't know whether I'll be able to answer it correctly. But I'll think of it maybe. But what I can say, there are not 3, but there were, I would say, infinite learning points that I have been through those 3 years, and I'm more of a guy who loves technology and driving project to some outcome. My major learning, if I have to say, is keeping the momentum So keeping the momentum is extremely important. If you are procrastinating at any point of time, consider that this is going to fail. I mean, there's a huge probability that you're going to fail. So you don't have to push it too hard at any point of time. You also have to do other stuff. So in our case, it was courses. So even I took some heavy courses in my semester where we were building the pot. But I would still say you need to manage it properly. Keep the momentum going and don't lose it. I mean, even if you go slow, it's fine, but don't lose the momentum. I can say that is one very important thing.
Yes, sir. And again, teamwork always makes the dream work. Yes. One final question which has come up is, yes, apart from Hyperloop, what are your thoughts, visions, and maybe your dreams for the future, perhaps 20 years from now?
I don't know, frankly speaking, but what I can tell is what I'm currently doing. So right now, I have passed all my work and my responsibilities to my juniors right now, and everyone at the institute who are in Avishkar Hyperloop third generation and fourth generation. They are taking the team ahead. They are organizing this competition and everything. I'm just guiding them and advising them. So right now I am working on space technology, and I'm trying to build a startup around space technology with some of the teammates who are there with me in Hyperloop. So that's the next thing that I'm trying to do.
So no other questions have come up. So I guess that brings us to the end of today's talk. Thank you so much, Suyash, for joining us. That was actually very insightful and also very engaging and interactive. So thank you so much.